The T-64 stayed the Soviet Union's most secret main battle tank for a long time, and it left a real mark on the history of armored warfare. In 1967, at a closed test range near Kharkiv, engineers put a brand new design through its paces. The tank showed an astonishing rate of fire. The crew sent 10 rounds downrange in just a few seconds, hitting targets 2 kilometers away. The officers watching the trials called the results exceptional, because at that moment, no other tank was doing anything like it. The designers had removed the loader from the crew entirely, handing that job over to a new automatic mechanism. This machine went on to influence tank design worldwide, and it pushed Western engineers to study its technical choices for decades. The groundwork for the project had appeared 10 years earlier, during the tense standoff of the Cold War. The mid-1950s became a period of intense rivalry between two superpowers. The Soviet Union and the United States competed across everything from missiles to armored vehicles. The pace of the arms race kept accelerating because both sides wanted an advantage on the battlefield. In 1959, British engineers fitted the Centurion tank with a new 105mm gun. It could punch through Soviet armor at longer ranges than earlier weapons could manage. NATO gained a tactical edge, and the Soviet leadership began looking for an answer. That answer became the T-62, adopted by the Soviet Army in 1961. Designers equipped it with a 115mm smoothbore gun that outperformed the British weapon in raw power. Parity was restored, but at the same time, specialists at the Design Bureau of Kharkiv Factory No. 75 began work on a different project in parallel. They were building a machine meant to leap far beyond the technological standards of the day. The project was led by the designer Alexander Morozov. Earlier during the Second World War, he had helped develop the T-34. After the fighting ended, Morozov stayed with armored vehicles, and under his leadership, engineers created the T-44 and the T-54. Years of experience let him challenge the usual assumptions. Morozov came to the conclusion that simply increasing gun caliber and armor thickness was an inefficient path forward. Those choices made tanks heavier and less maneuverable, while the strain on the crews rose sharply. The situation demanded a fundamentally new approach. The biggest problem for tanks of that era was still the loading process. As calibers grew, the shells became larger and heavier. A loader needed serious physical strength to keep lifting bulky ammunition and ramming it into the breech over and over again. In the heat of battle, a person would fatigue quickly, and the rate of fire would inevitably drop. For example, a T-62 crew could manage only 4 shots per minute, and at the time, specialists considered that normal. Morozov decided to remove the human factor from loading entirely. Engineers had discussed automating this step for years, but no one in the world had managed to make it work on a mass-produced vehicle. Developers kept running into a long list of technical problems, simply because the task was so complex. Even so, the engineering team kept going and focused on building the right mechanism. They designed a system that stored shells and propellant charges inside a rotating container. The gunner would simply press a button on the control panel, and the automation would locate the correct type of ammunition, pull it from the stowage, and feed it into the gun. In 1962, the Design Bureau presented a prototype designated Object 432. This vehicle was radically different from anything else in world tank design at the time. The engineers cut the crew down to 3 because the loader's job had been taken over by the machinery. They also reduced the tank's overall height to 2 meters and 17 centimeters, making it a harder target on the battlefield. With these technical choices, the new system pushed the rate of fire to 8 shots per minute, about 2.5 times higher than what other tanks of that era could achieve. The autoloader was only one of the innovations built into the vehicle. The Kharkiv team also introduced composite armor for the first time in tank history. Between 2 steel layers, they placed a special filler that effectively resisted shaped charge rounds. This armor weighed less than an all-steel equivalent, but provided a much higher level of protection. The tank's frontal armor could withstand hits from the widely used 105mm guns of the period. Its running gear, with small road wheels made from an aluminum alloy, stood out for having the lowest weight among vehicles in its class. At that point, Object 432 existed in only a single example, and it had to go through an intense testing program. The military had no intention of adopting the vehicle until it proved its reliability under the toughest conditions. Factory trials began in 1962, and the results came back strong. The tank demonstrated an unusually high rate of fire for its time. The autoloader operated steadily, and the composite armor absorbed hits that would typically penetrate other contemporary designs. The next stage took place at military proving grounds. Test crews drove the prototype through sand and mud, forced it across water obstacles, and pushed it up steep climbs. The vehicle had to confirm it could function in different climates, from hot deserts to the cold northern latitudes. Specialists deliberately created extreme situations to expose weak points in the design. And during those trials, they did uncover certain flaws. The main problem was the engine. The developers installed a new diesel rated at 700 horsepower, allowing the tank to reach speeds of up to 65 kilometers per hour. The engine was made more compact and lighter than earlier designs, which let them significantly shrink the engine and transmission compartment. With that layout, the tank gained a low profile and became less conspicuous. But downsizing came with technical complications. The engine turned out to be extremely sensitive to fuel quality and to strict adherence to operating procedures. Even minor violations of the maintenance rules caused breakdowns, so engines from the first production batches often failed. The project leadership understood clearly that without a reliable power plant, the tank could not fully perform its mission, so the Design Bureau launched a large-scale effort to refine the engine. Engineers analyzed every failure in detail, identified the causes, and introduced effective technical fixes. At the same time, engineers were refining other parts of the vehicle as well. They paid special attention to the autoloader because there was nothing like it anywhere else in the world, and no one had any real operating experience to draw on. While the designers worked through the technical issues, the country's military leadership followed the trials closely. The Cold War was still in full swing, and the Soviet Union needed a new generation of tank. Western countries weren't standing still either. Their specialists were designing their own next-wave combat vehicles. The moment demanded speed, but the command had no desire to accept a half-finished machine. Object 432 was tested under strict secrecy. Many high-ranking defense officials didn't even know it existed. Western intelligence services had no information about the Soviet Union's new development either. By the middle of the 1960s, specialists had successfully eliminated the main shortcomings. The engine's service life increased sharply, the autoloader ran reliably, and the suspension proved itself in the harshest conditions. In 1966, the command made the decision to adopt the new vehicle for the Soviet Army. The tank received its official designation, the T-64, and under that name it entered the history of global tank design. The production model had a combat weight of 36 tons, noticeably lower than Western vehicles in the same class. At the same time, the T-64 surpassed them in firepower and protection. Its 115mm gun allowed the crew to engage enemy tanks at ranges of up to 2 kilometers. A shaped charge round could penetrate armor up to 450mm thick, which meant it could destroy virtually any armored target of that era. Alongside the main gun, the designers also equipped the tank with a 7.62mm machine gun for use against infantry. Another major step forward was an optical range-finding sight, appearing for the first time on a Soviet tank. Before that, gunners had to estimate distance by eye, or rely on bulky external rangefinders. The new system could measure distance instantly and with high accuracy. The gunner would set the sight for the chosen type of round, apply a correction for the tank's own movement, and then a dedicated calculator would automatically determine the aiming point. Compared with earlier models, this dramatically increased the chance of hitting the target with the first shot. The T-64 crew consisted of 3 people. The commander sat in the turret, watched the battlefield, and made tactical decisions. The gunner sat to the left of the main gun and controlled the fire. The driver mechanic was positioned in the front of the hull and was responsible for maneuvering the vehicle. Operating this tank demanded high qualifications from every crew member, specific knowledge, and real skill. It was a complex weapons system, built with some of the most advanced technology of its time. The Kharkiv plant that designed the model soon moved into full-scale production. When the first vehicles reached frontline units, crews finally had the chance to get hands-on with the new equipment. And one feature stood out immediately as a major change: there was no loader. With the press of a button, the new mechanism automatically fed rounds into the gun. Commanders of the tank units that received the first production vehicles ran into new challenges right away. This tank demanded a completely different level of training from its personnel. Crews who were used to the simpler T-54 and T-55 approached the new machine cautiously. The autoloader, along with the sheer number of instruments and switches inside the fighting compartment, made the early learning curve much steeper. Bringing the new tank into service came with a series of very practical difficulties. And in the first months, one problem became especially clear. Drivers who had trained on earlier models carried old habits over to the new vehicle. They often ignored the requirement to warm up the engine, used fuel of the wrong quality, and broke the maintenance schedule. The diesel responded to that kind of misuse with frequent breakdowns. In some units, the number of tanks out of action rose sharply, forcing commanders to pay close attention and look for solutions. The issue wasn't the tank's design, it was the human factor. The military created specialized training centers to prepare T-64 crews. They sent their best officers and sergeants there for an intensive course. Instructors explained how the new tank needed to be operated and trained them to handle the autoloader and the optical range-finding sight properly. When these specialists returned to their units, they became mentors for everyone else. Gradually, the situation improved. Crews learned to operate the tank with more confidence, understood its quirks, and began using its full capabilities. The number of technical failures dropped sharply, and the combat effectiveness of the units rose. Tankers quickly came to appreciate the autoloader because it allowed them to fire at a much higher tempo. In training battles, T-64 crews consistently beat units still operating older models. 8 shots per minute versus 4 meant the new tank could hit the notional enemy before the other side even finished aiming. Specialists also paid close attention to the effectiveness of the sighting system. During exercises, gunners showed strong accuracy at long distances. The optical rangefinder made it possible to determine range quickly, and the ballistic calculator automatically worked out the necessary corrections. Experienced gunners were hitting targets with the first shot from distances beyond 1.5 kilometers, results that had been recorded only rarely before these systems appeared. Western tank crews of that period didn't have comparable equipment, so they determined firing parameters mostly by eye and by experience. The military also gave high marks to the tank's low silhouette. A height of 2 meters and 17 centimeters made it much harder to spot and engage a T-64 on the battlefield. Against hills and uneven terrain, the vehicle could become difficult to pick out visually. Commanders actively used this advantage, choosing positions that let crews fire from concealed points. Combined with a powerful gun and a high rate of fire, that tactical approach significantly increased the T-64's overall effectiveness. The suspension, with its small aluminum alloy road wheels, proved itself in real service as well. The design turned out to be sturdy and reliable in operation. The tank handled rough ground, water obstacles, and steep slopes without major trouble. Drivers noted how controllable it felt and how smooth the ride was. Those small diameter road wheels also made the T-64 visually distinct from other tanks. And over time, that detail became one of its signature features. At the same time, the Design Bureau under Alexander Morozov kept refining the tank. Real service experience in the field provided a steady stream of information about which components and assemblies still needed work. Engineers continuously adjusted the design to improve reliability and overall performance. New materials and manufacturing techniques gradually allowed them to extend the engine's service life. Specialists also improved the autoloader's operation and expanded the capabilities of the sighting system. In parallel, the team began working on a deeper modernization of the tank. The designers were watching Western armored development closely, and they understood that sooner or later, new vehicles would appear that could effectively challenge the T-64. To maintain parity or stay ahead, they chose a clear main direction for modernization: stronger firepower. Even though the 115mm gun was already a strong weapon, the Kharkiv Bureau began developing a new gun to push the tank's striking power even further. In May of 1968, the Soviet government approved series production of a new variant, designated the T-64A. This version introduced new armament that changed how tanks were equipped at the time. Its 125mm smoothbore gun was dramatically different from existing counterparts around the world, and that advantage in firepower over other tanks would remain noticeable for years to come. Integrating the new gun created a fresh set of engineering challenges. The larger caliber meant stronger recoil, so the designers reinforced the stabilization system and the gun mounting. The heavier, larger rounds forced engineers to redesign the autoloader. They solved these problems while keeping the fighting compartment compact and preserving the original rate of fire. Even with the bigger ammunition, the loading mechanism still delivered 8 shots per minute. The modernized tank's combat weight rose to 38 tons. Even so, the 700-horsepower diesel engine maintained the necessary mobility. Top speed reached 61 kilometers per hour, allowing the vehicle to maneuver effectively on the battlefield. The crew still consisted of 3 people: the commander, the gunner, and the driver mechanic, and each one required specialized training to operate the tank properly. The arrival of the T-64A also had a major impact on how armored vehicles were classified. Until then, tanks were traditionally divided into light, medium, and heavy categories. Light tanks were fast and agile, but had weaker armor and armament. Medium tanks balanced those traits as a compromise. Heavy tanks carried thick armor and big guns, but were slower and less maneuverable. The new model forced a rethink of that established system. The T-64A combined qualities that specialists had previously considered incompatible. In mobility and maneuverability, it matched the best medium tanks. At the same time, its 125mm gun outclassed the weapons on every heavy tank of that era. Its composite armor offered protection on a heavy tank level, while the low silhouette made it far harder for an opponent to aim accurately. Soviet military theorists introduced a new term for this kind of universal vehicle: main battle tank, and that concept quickly spread worldwide and became standard in military language. Other countries soon recognized that the old split between medium and heavy tanks was no longer useful. Designers in leading states began developing their own main battle tanks, using the characteristics of this machine as a reference point. Competitors needed time to create true counterparts, because the designers of the T-64A relied on specific technological solutions that Western engineers simply didn't have yet. Meanwhile, the Design Bureau kept improving the vehicle, and in 1976 the engineers introduced a new variant. The T-64B gained a capability that drew serious attention from military specialists around the world. This tank's crew could fire guided missiles straight through the barrel of its main gun. In practical terms, that meant the gunner could engage a target at ranges out to 4 kilometers, about twice the standard tank fighting distance of the era. After the press of a button, what left the barrel wasn't a conventional shell, but a guided missile that flew precisely toward the target. That missile armament allowed the tank to strike not only other armored vehicles, but a wider range of battlefield targets as well. The T-64B could effectively hit fixed firing positions, fortified points, and small targets at significant distances. The guidance system delivered high accuracy, and the missile's warhead inflicted serious damage on whatever it reached. At the same time, the tank retained the ability to fire conventional ammunition. That made it a truly versatile combat vehicle, able to handle different missions on the battlefield. For a long time, Western intelligence services questioned whether such a technology even existed. The concept of launching missiles from a tank gun sounded unrealistic because no one had successfully implemented it before. But once performance data reached the West, it caused real concern. Military analysts began revising their assessments of the balance of forces in Europe, while engineers looked for ways to counter this new threat. The vehicle also became a testbed for a whole series of new technical solutions. Innovations proven on the T-64 were used as the foundation for the next generations of tanks. Engineers at other plants studied the Kharkiv Bureau's experience and adapted those ideas to their own projects. In that sense, the characteristics of a single tank shaped the development of the entire field for decades. Specialists at the plant in Nizhny Tagil closely analyzed the work coming out of Kharkiv. Local designers were tasked with creating a simpler and cheaper vehicle that still preserved the key advantages of the T-64. The result was the T-72. The new tank inherited the autoloader, the 125mm gun, and the three-man crew concept from its predecessor. That tank went on to become the most widely produced in the world. Dozens of countries adopted it, but its existence ultimately traced back to the Kharkiv design. At the same time, engineers in Leningrad were working on a gas turbine tank. Designers at the Kharkiv plant used the T-64 as their starting point and replaced the diesel with a gas turbine. That became the T-80. This vehicle delivered high road speed and rapid acceleration. Its fighting compartment layout, weapons system, and autoloader all directly carried over the Kharkiv design, so the three Soviet main battle tank lines, the T-64, the T-72, and the T-80, shared a common design foundation and developed the same engineering concept. Designers in other countries spent years studying the features of this machine. Engineers in the United States, Germany, the United Kingdom, and France tried to build their own autoloaders. But for a long time, they couldn't achieve the results they wanted. The mechanism the Kharkiv specialists developed back in the early 1960s was extremely difficult to copy. Only decades later did engineers in other countries manage to build systems with similar performance, and even then, not everyone succeeded. Tanks like the Abrams in the United States and the Leopard 2 in Germany kept a four-man crew, with a dedicated loader manually ramming rounds into the breech. The composite armor first used on the T-64 later became a standard feature on most modern tanks. The idea of layered protection, with a filler material sandwiched between steel plates, proved highly effective against shaped-charge munitions. Western designers created their own versions of this kind of armor, but the first major breakthrough in the field belonged to the Soviet Union. A modern tank's ability to survive hits from anti-tank missiles still relies, to a significant degree, on the technology the Kharkiv Design Bureau introduced more than half a century ago. The optical range-finding sight installed on the T-64 marked the beginning of a new era of high-precision tank gunnery. Modern fire control systems, with laser rangefinders, thermal imagers, and ballistic computers, grew out of the same basic idea. That device allowed gunners to engage targets at distances far beyond what comparable systems of the period could handle. And the concept of automating the aiming process, which the Kharkiv designers implemented in this tank, set the direction for tank sighting systems for decades. The main battle tank concept, introduced alongside the T-64A, gained universal status in armed forces around the world. Today, armies no longer divide armored vehicles into medium and heavy categories. That classification disappeared along with the machines of earlier generations. Modern tanks are designed as universal combat platforms, expected to handle the full range of battlefield tasks. Historically, the very term main battle tank traces back to the work done at the Kharkiv Design Bureau. Factories produced the T-64 and its variants for many years. The Soviet military deployed thousands of these vehicles near its western borders as part of strategic deterrence. Crews who operated this complex, demanding machine often highlighted the reliability of its armor protection and its high technical performance compared with other tanks of the era. For a long time, the T-64 remained one of the core elements of the country's armored arsenal. Alexander Morozov, the designer who had once worked on the T-34, ended his career by delivering another truly major project, one that reshaped global approaches to tank design. The T-64 established the foundational engineering solutions for a whole line of later Soviet and Russian tanks, from the mass-produced T-72 to more modern armored vehicles. And the technical decisions built into this machine 60 years ago are still alive today. Modern designers continue to use these concepts when they shape armor protection and firepower for new generations of combat vehicles. The story of this Soviet tank is a clear example of how military technology evolves over time and how engineering thinking from the last century can keep influencing tank design around the world.